Well, dear students, now again there is question 13.9 of NCRT book. A good question and very important. Good to learn the things and important to get marks in the exam. Obtain the amount of 27 CO cobalt 60 to obtain radioactivity, the rate of to obtain rate of activity of 8 millicurie. 8 millicurie. T half for this is 5.3 years. So for students who never open the book or never listen teacher, this is very difficult question, but it is very simple question for you. I told you that RT equal to lambda and T, don't forget this. Lambda equal to 0.693 upon T half into NT. Now T half here, it is 5.3 years. How many seconds? 3.16 times the power 7 seconds. Remember this. 1 year equal to this. Actually, this is root 10 nearly. This is root 10. 3.16. It is equal to root 10. 6 plus 1, 7. Now you need NT. Number of नहीं क्या निकालना है फाइंड मास करना है मास तो फ्रॉम हियर वी आर गिवन 8 millicurie rate तो 8 millicurie means 8 into 3.16 10 to the power 7 0.693 upon T half 5.3 into 3.16 10 to the power 7 और एंटी निकालना है तो हियर यू गेट एंटी इक्वल टू 8 into 3.16 10 to the power 7 and into all this thing 5.3 into 3.16 10 to the power 7 upon 0.693. So here exact answer is not the meaning. Procedure is the meaning here. Try to understand the procedure. So I told you this is into this 10. 8 into 10 into 5.3 into 10 to the power 14. Take this nearly 7.7. Then again very simple here. 8 is 24, 2, 8 5 is 40 or 2 42. 8 is 24 carry 2 into 10 to the power 16, 15 upon 0.7. If I divide by this, it will come out to be 7, 6. इसको हटा दें 7. It is 424 divided by 7. 7 is 42, 40.075. So it comes nearly 60.5 into 10 to the power 15 or 6.05 10 to the power 16. This is the number of atoms with cobalt 60 which will produce rate of 8 millicurie. You are asked mass of the cobalt 60. तो mass of this atom of cobalt 60. I keep on emphasizing the meaning of mole concept. Now we know mass of 6.02, 6.5 10 power 16 atoms of 27 CO is equal to 60 upon 6.023 10 to the power 23 gram will be the mass of one atom of cobalt, because 6.023 10 to the power 23 atom of cobalt has mass 60 gram, so one atom is this into 6.05 10 to the power कितना भाई 16, and it comes out to be this cancelled 6 into 10 to the power 17 minus 23, so nearly 6 into 10 to the power minus 6 gram. इतने ग्राम of cobalt 60. See how much it is. It is 6 into 10 to the power minus 3 milligram. This much of will produce rate of 8 millicurie. Cobalt 60 is very commercial radioactive element, isotope of carbon cobalt 60 used in medicines etc. Once in some raw material there was cobalt 60 found in New Delhi. So that spread rate of radioactivity and people start getting. So because the number of atom in milligram is very large, so such a high rate can be produced. Now next question is there 3.10, 13.10. These are important questions for you, dear student. Question says half life of 38 strontium 90. For this T half is 28 years. How many seconds? 28 into. If you use again and again, you get learned by heart. जैसे कि आपके जनगणमन दिन आगे याद हो रहा है. तो what the disintegration rate of 15 milligram? 15 milligram of 38 strontium 90 से क्या रेट होगी? 15 milligram. How many gram? 15 milligram. 15 10 to the power minus 3 gram. ग्राम में क्यों क्या? बिकॉज 90 ग्राम ऑफ strontium has 6.0 10 to the power 23 atoms. So you are asked what is the rate from 15 milligram of strontium 90 if half life is 28 years. So you know, matter is simple. We know RT, lambda and T. Lambda 0.693 upon T half. T half 28 into 3.16 10 to the power 7. And T 6.023 10 to the power 23 upon 90 into 15 into 10 to the power minus 3. गलत होगा मामला, बन नहीं रही बात यहाँ. सॉरी, मैं दोबारा कह रहा हूँ बच्चों. RT इक्वल टू लैम्बडा NT है, तो लैम्बडा 0.693 अपॉन T हाफ. T half is 28 into 3.16 10 to the power 7 second. NT 6.023 10 to the power 23 upon 90 into 15 milligram, 15 into 10 to the power minus 3. 15 is 90. 0.7 into 6.023 10 to the power 20 upon 6 into 28 into 3.16 10 to the power 7. So if we solve this, कुछ गड़बड़ होगा. अच्छा ठीक है. तो इट इज नियरली 6. It is equal to 7 upon 28 into 3.16 and 10 to the power ये हो गया 8 और 20 minus 8 12. So if we solve this, it will get nearly 8.3. 8 into 10 to the power 10. ये आंसर होगा. नहीं 8 into 10 to the power 7 सॉरी. इतने BQ will be the rate of activity obtained from 15 milligram of uranium. You can convert this into millicurie divided by 3.16 10 to the power 7. तो 7 कट जाएगा तो something 2 point something millicurie. Millicurie is a bigger unit. Now I come to a question of half-life. There is short example of NCERT book. It is example 13.5. Tritium means 1H3 has half-life 12.5 years. T half for tritium is this. Again undergoing beta decay. After what fraction of sample of pure tritium will be remain undecayed after 25 years? So NT upon N0, I told you what is NT, number of radioactive nuclei left undecayed after time T. If initially it was having N0, 1 upon 2 to the power N. N is equal to T upon T half. So here T is equal to 25 years and T half is 12.5 years. So it is 2. So it is 1 upon 2 to the power 2 यानी कि 1/4. The 1/4 will remain undecayed. ठीक है भाई? Now I take question from other book. देखो though I have a lot of problems in my brain, but I want to tell you the standard questions which are asked in exam. Here the question which always confuses the students. Half-life of radium T half for radium is 1600 years. I told you that half-life varies from million microsecond to billion of years. So half-life of radium is this. What fraction of sample of radium will this be integrated in T equal to 6400 years? पूछा क्या आपसे? What fraction of sample of radium will be disintegrated? What fraction will be disintegrated in 6400 years. So problem is that we know N_T upon N0. We obviously think like this. Is equal to 1 upon 2 the power n. Here n is equal to 6400 upon 16 in 4. But what is N_T upon N0? It is N_T the number of radioactive nuclei left undecayed. ये कह रहा what percent will get decayed? Means you need to find out here N0 minus N_T upon N0 कितने बचे रह जाएंगे तो पहले से निकाल लें. तो N_T upon N0 जो है which left undecayed will be 1 upon 2 the power 4 यानी 1 by 16. So if I write 1 N_T minus N0 trick वो घट जाएगा इसमें तो 1 minus 1 upon 16 तो N0 minus N_T upon N0 15 by 16. This is the answer. Actually you are asked here how much what fraction get decayed. This is the number of radioactive nuclei decayed divided by original number. So we have to be very cautious while attempting the question because sometimes it appears that it is the question which I know and we commit the mistake. I myself make many mistakes. You might be observing just now I was revising some watching video. तो I have written one thing wrong. लिखना था derivation of force on current carrying magnetic लिखा गया क्या derivative of. तो derivative something different. तो ये मिस्टेक होती रहती है कई बार जाने अनजाने में. तो we must use our common sense to understand what mistake we can do and so I hope you will enjoy these questions. In next video I will be telling more question on radioactivity and rate of radioactivity etc.